And on one of Jupiter's 4 largest moons may lie the answer to an important question. Beneath these vast sheets of ice, mankind could finally discover if alien life exists. Cutting-edge space missions are unlocking the secrets of the enigmatic giant, Jupiter. In the last 50 years, space missions have revealed worlds we could never have imagined. From the mountains of Mars to the methane lakes of Saturn. Yet one planet seems to capture our imagination more than any other. The greatest of them all, Jupiter. Most of what we know about Jupiter comes from one space mission, Galileo, launched aboard the space shuttle Atlantis in 1989. Each new discovery it made deepened our understanding of Jupiter and its moons. It hoped to uncover evidence of how the solar system itself was formed. 11 times bigger than Earth, yet probably without a solid surface, Jupiter is a ball of gas and liquid 145,000 kilometers across, with lightning superbolts 1,000 times more powerful than the strongest strikes on Earth, and a ring system like Saturn's, but too faint for our telescopes to see. The Great Red Spot, a single vast storm with 250-mile-an-hour winds, so huge it could swallow the Earth 3 times over. 63 moons orbit this giant. Galileo set out to study 4 of them: Io, Europa, Ganymede, and Callisto.
Each of which would be a beautiful target for a space mission in and of itself.
Scientists expected dead and lifeless worlds 800 million kilometers from the Sun. Io, Jupiter's closest moon, is slightly larger than Earth's own moon, but Io is far from lifeless. Huge plumes of sulfur dioxide reach hundreds of kilometers into space.
Very peculiar surface with reds and yellows. Someone nicknamed it the pizza moon.
Ganymede, the largest moon, is a world of scars and frozen slush. And Europa, most mysterious of all, its icy surface may hide a liquid ocean below. And where there's water, there could be life. A new generation of probes is set to explore the mysteries of the Jovian system: Juno, Europa Explorer, and the underwater probe Endurance. 3 missions with one goal: to reveal the secrets of these alien worlds. Before Galileo, previous missions could only look from afar. In the 1970s and early 80s, Pioneer and Voyager gave us tantalizing glimpses of Jupiter and its moons, but they raised more questions than they answered. How did Jupiter form? What powers its vast storms? And why are its moons so geologically active? Before these questions could be answered, the team had to overcome a simple problem. Galileo was unable to carry enough fuel to reach its destination. NASA engineers needed another way to get to Jupiter.
And they came up with a brilliant solution. We wouldn't go to Jupiter at all. We'd start by going to Venus.
By flying close to Venus and then Earth, using a gravitational slingshot method, Galileo stole some energy from the planets to accelerate itself towards its final destination, Jupiter. When Galileo arrived, after a journey of 6 years, a small sub-probe was to detach and plunge into the depths of Jupiter's atmosphere. it would have less than an hour to analyze its surroundings before being crushed by the extreme pressure. Everyone expected Galileo to beam back extraordinary information. But first, it had to get there. Just 18 months after launch, disaster struck. Galileo's umbrella-like radio antenna failed to open.
It was beyond devastating. It had to open.
Without that antenna, we thought that the spacecraft would basically not be able to complete its mission.
Back on Earth, NASA engineers scrambled to fix the problem.
There were attempts to jolt it open. They thought perhaps it had just gotten stuck. There were attempts to, kind of go up and down, to try to get it to open.
There was now only one way to keep the mission from total failure. Use Galileo's secondary low-gain navigation antenna to send data back to Earth. But there was a big problem. The low-gain antenna transmitted 10,000 times slower. Just a few % of the data Galileo gathered would ever make it back to Earth. As the spacecraft neared the end of its journey, it coincided with a massive comet on a collision course with Jupiter. Galileo was in an ideal position to watch. It might be able to find clues to one of the most important questions about Jupiter's history. How was it made? Previously, scientists believed that Jupiter was made from the leftovers from the birth of the Sun, a primordial planet frozen in time. If this were so, then the Sun and Jupiter would have very similar chemical compositions. The comet's impact would stir up chemicals from below the surface, enabling the team to analyze them and see if the theory held true. They were about to get more than they bargained for.
I just couldn't believe that we were going to get a chance to see one body in the solar system smash into another one.
We had an up-close and personal view of this unique event.
The comet's name was Shoemaker-Levy 9. David Levy was part of the team that first discovered it.
This was going to be the first time that a comet collided with a planet, the first time in recorded history. And we had no idea what we were going to learn from it.
The day arrived. On mountaintops and in space, more telescopes were trained on the same part of the sky than ever before. As the comet approached, Jupiter's massive gravity tore it to pieces. 20 separate fragments would strike the planet, some more than 1.5 kilometers across. Astronomers across the globe were about to witness something amazing.
Yeah, that's it.
One by one, the fragments hit. The largest released as much energy as 300 million atomic bombs. A fireball shot 3,000 kilometers above the top of Jupiter's clouds. Each fragment produced a separate impact cloud, visible as dark black bruises in Jupiter's southern hemisphere. They were the size of the Earth.
The first thing we saw with each impact was either the plume of dust and gas as seen by either Galileo or the Hubble Space Telescope. The next thing we saw was the formation of the large jet black cloud all over Jupiter's southern hemisphere.
But the real surprise didn't come from the clouds. It came from the shock waves the impact sent through the upper atmosphere. There was only one explanation, and to astronomers, it was a revelation.
When Shoemaker-Levy 9 crashed into Jupiter, it's sort of like a rock going into a pool. It sent out waves, and the speed of the waves depends on the amount of water in the atmosphere. And the speed was faster than we thought, and so we inferred that there was more water than we had expected. You can sort of see it here. You can see the ripples spreading out. And it was the speed at which the circles grew that told us there was more water than we expected.
The discovery was a surprise. It meant that the composition of Jupiter was different from that of the Sun. It threatened to overturn everything scientists thought they knew about Jupiter's formation. A new theory was needed. In 17 months, Galileo would arrive and analyze Jupiter's chemistry firsthand. Only then could the team hope to solve the mystery. 1 year after the comet Shoemaker-Levy 9 struck Jupiter, the probe Galileo was on its final approach. Evidence already collected had led scientists to believe Jupiter may have 10 times more water than previously thought. If so, they would need to find a whole new explanation for how this strange world formed. Galileo's first task would be to measure the chemistry of Jupiter's atmosphere, including the amount of water. Galileo would release a small probe into Jupiter's clouds. The probe would also measure the wind speeds and temperatures at different depths to try and explain why the weather is so violent, as well as answering the big question: is Jupiter a long-lost cousin of the Sun, or something else entirely?